Okay.
Wait, what?
Is there?
On here. The ones that we created.
B1 has to be greater than.
For the alternative. It's
for the
either equal to or greater than 0.
The true linear regression equation is. My guess is it's just going to be equals B1 for your null equals 0 and your alternative doesn't equal 0. If you look at the reading, 4.1 or 4, section 4, hypothesis test for regression coefficient says, in other words, the independent variable x does not affect the value of the dependent variable y. The null and alternative hypothesis for this test are
Yeah, I agree.
H your null is 0, the alternative is not equal to 0.
Okay. So C.
Right? We agree on that?
Yeah.
C.
Residual.
This
Residual for an observation is defined as a difference between the observed value of y and the value that would have been predicted by the regression.
so the
So
difference
B.
between
B?
B,
Spell it.
B, E, E,
B? B? Wrong. A plot of residuals supports using linear regression when
I think it'd be when you see a pattern in the residuals, right? Because
residual plot.
so
So wait, what are we looking for?
There's no obvious pattern in the data.
Plot of residuals supports using linear regression. Residual plot supports
this.
linear regression is appropriate, and the residual plot will show no patterns and will consist of random scatter. There is a pattern in the residuals, which suggests that linear regression is not appropriate. So
That's
plot of
not
residual
even-
supports using linear regression when
That doesn't make any sense.
doesn't. Let's see right here. I'm reading this right.
Where are we at? Okay.
The residual plot shows random scatter. There is no obvious pattern in the data. If linear regression
There
is
is no
appropriate, then the residual plot will show no patterns and will consist of random scatter.
No pattern in the residuals.
But that's not an answer. You will see a pattern, or the residuals will look normally distributed with zero mean. Is that the answer?
It's terribly
Terribly worded, but I'm gonna guess that it is that they look normally distributed with zero mean, because if you look at this chart, the line is right at 0,
I
and
agree
they're
with
scattered completely around it.
that. I agree with that.
Because they're not all going to see the megaphone shape, and there's not a pattern.
Yeah. Compute the residuals from the mass cell efficiency data using software. Use the confidence data as the explanatory variable.
Like,
What?
I'm going to do this. What is it? Compute the residuals for the math self-efficiency. Using software. Is the confidence data.
Okay, so what's the data file called?
Math self-efficiency.
And which one do we use the confidence?
you're using the confidence data as an explanatory variable and the score data as a response variable.
Okay.
So your explanatory is going to be your x, and the response is going to be your y.
Your shoe could be something wrong with my computer. Your shoe's squeaking. Sounds like it's coming from the computer.
On my shoes.
Yeah, I've been thinking something's wrong with my computer.
So
What the
this
heck
one we
is going
need
on?
the inference.
Yeah. I'm trying to download the.
I have it. Okay, so we use, is it the two sample t-test? Is the file score and copy?
Find the residuals, so you need to make a scatter plot.
Right. They have that file. Right.
So I wonder if that
QQ.
file that we have to use.
Okay.
Scores?
Damn. Confidence as an explanatory. Score as a response.
I have the spreadsheet, the linear regression.
For the map. And find out the residual. What state meant best? Right. Because my guess wrong. I'm not going to be the residual. Yeah, negative. I'm not going to. My guess is it's going to be that they're all. Looks like they form.
They're under 50 and they're above 100.
Well, then it's going to be C. The residuals form a linear pattern.
I guess.
Yeah.
Okay, and then 7, based on the QQ plot for these residuals, what can you say? The residuals are clearly not normal. They look right skewed. They are fairly normal.
I think they're fairly normal. Can you say?
Those are the data on your sheet. That's what So we do not have evidence of non-normality in the residuals. Normal distributed based on the QQ plot that we have here.
So, yeah,
So I
If
think
it's-
they are fairly normal.
show a straight line. They're considered normal. It shows a straight line.
But it doesn't, so it'd be fairly normal.
It goes in
Yeah, that's what I was saying.
the direction.
Yeah, it's like a full line
There's a clear
with hardly any
direction.
outliers. Yeah.
So, I mean, there's outliers, but there's a clear direction of where it's all going.
And there's not like a ton of outliers.
Of the math self-efficiency data, given the scatter plot, residuals plot, and the QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply.
Well, I'm going to say
There's,
there is a linear relationship
Yeah.
between x and y. The residuals are normally distributed. We've already figured that one out.
I don't think C is one. The variance of the error turns is constant because it's not. It's
X value is measured without error. How do you know?
I was going to say, you can't really tell that one, can you?
I don't think the observations are necessarily independent. Are they, or are they? Because they're
I'd say
well.
I would
So
say yes, they're independent because one observation didn't affect another
true.
one.
but the have the x measured. I'm not idea on that. It's really good.
It keeps going back to the one that I have open. That is on the big thing when I'm trying to look at the small one. Hey, look. If I try and scroll down, it comes back to this one.
What the heck?
Click in there and scroll down.
That sucks.
I don't know what's going on.
Yeah, I don't know.
I think we should just leave it.
I think it's those ones. Okay, now we need to figure out the slope of the line.
There's B1 estimate. Slope.
So you can have it insert a line.
Short. And
Yeah. So, you can have it
linear forecast from
linear. And then
These are
you can have this equation as well, and that will be the this one.
12.725.
What is the confidence interval?
It's forward slope
for B1. Yeah,
10.708.
14.742.
Wow, I'm really surprised. 14 A.
And then based on the evidence and using level of significance alpha equals 0.05, what decision can you make regarding the hypothesis test for B1?
T is 12.4. P value is 2.4
2.4.
times 10 to the negative. So that
Did you
Zero,
no
zero,
change that to the drop down equal to nullity?
Zero, zero.
failed to retire? No, we
You
rejected
reject
it.
because the
Sorry, I was
p-value is
thinking
larger.
backwards.
Yeah.
I was
Yeah.
thinking backwards.
Yeah.
So that one. And then for hypothesis test for B1 slope, you reject the null. What does it mean? There is sufficient evidence to conclude that the slope of the reject graph, the regression line, is
Not zero.
Time, value,
scattered as your y-axis. So I'd say your head length.
Dependent?
Right? Or would it be the body length? The body length depends on how big your head is. Say you're going to be.
It says unstandardized or an unstandardized residual in head length.
Okay. So the head, the body length.
the second one.
That's what I was going to say. 7.124 and 8.311. What can you say?
Since 99% confidence it is.
95% chance the confidence interval will contain the true value of B1.
Yeah, I think it'd be B. Alright.
Okay, guys.
Boy. Bye.
Bye.